Good afternoon, everyone. This is Ernie Gallo. Thank you for joining us for our ATIS webinar that will be looking at upcoming changes to NFPA 855, which is the standard for installation of stationary energy storage systems. And we appreciate everybody joining us. If we can go to the next slide, we'll go over the agenda. So we'll go through some introductions. We have two excellent speakers today, and Curtis Ashton and Rich Kluge. We'll discuss who is ATIS and who is ATIS PEG. Then we'll go into a little bit of the background of the fire codes and battery regulations. This is becoming more and more prevalent. I'm sure we all hear about issues with lithium batteries and fires. And so the NFPA is trying to address that, and how they're doing that through many standards, and one of them primarily being 855. So we'll go over the 2020 revision a little bit, and then we'll talk about the key changes to the 2023 Telecom as it relates to Telecom. And NFPA, most of their standards are on a 3-year cycle, and we're now getting very, very close to the 2026 being published. In a week or two, we'll be meeting at the NFPA annual meeting, where there's a high likelihood that the 2026 will be improved. And then we'll talk about, the evolution and continuing work of NFPA 855, and we'll open up for questions. This webinar is being recorded, and an email will be sent to all participants who registered in a day or so, and you'll be able to get the recording as well as a copy of the slides. Next slide, please. So by way of introduction, my name is Ernie Gallo. I work for a company called Members Curtis, and a little bit about my history. I graduated from college in 1981, worked for Underwriters Laboratories, then worked for Bellcore, which was part of the Bell system, which became Telcordia, which was purchased by Ericsson, and then several years ago, myself, Richard, and another fellow, Helmut Kinnair, joined and formed our own company, Members Curtis. We were known for many years as the NEBS Group, so the thought was, well, we'll be the NEBS company. But unfortunately, NEBS was taken by the New England Barbecue Society, so we couldn't use NEBS as our company name. So we combined it with our previous history of Bellcore, and that's how we became NEBS Corps. And we get involved in a lot of standards work, and represent various carriers and supplier testing work that we do. I currently sit on the ATIS board. ATIS is the Alliance for a Telecommunications Industry Solution, and participate in several ATIS groups. The ATIS PEG group, who's hosting this, as well as ATIS STEP, which is the Sustainability and Telecom Energy and Protection Committee. In that group, we're broken up into 4 little working groups. One deals with electrical protection, one deals with network power, one deals with telecommunications solutions in regard to energy efficiency, and the other deals with physical protection requirements. And ATIS can always provide more information. You can go to the ATIS website and find that out. I participate in several standards organizations, NFPA 1, which is the fire code, the National Electrical Code, 70E, which is electrical safety in the workplace, and NFPA 780, which deals with lightning protection, and NFPA 855, which is energy storage systems. A lot of people think of it as the battery standard, but it's a lot more than that. And the IEEE, the National Electrical Safety Code, which is kind of the outside plant version of the NEC, produced by IEEE, the Wireline Subcommittee, and the Low Voltage Data Communication Signaling Committee, so as well as the Optical Committee. So I spend a lot of my time doing standards work, primarily in the safety area. It's an interesting world, writing standards, and you'll find out when you go through 855 or any standard, the process. Standards tend to have their own language when you review them, and things that you think might be simple take us a long time to develop in the standards world. Recently, we had a big discussion as what is a kitchen? Now, everybody think that's pretty simple. It's a place where I have a refrigerator and I prepare food. And then somebody brought up, well, what if I have a small refrigerator and I make sandwiches at my desk? So those are the kind of things we talk about in the standards world, and we'll give you a little bit of insight on this presentation about 855. Next slide, please. So again, this is being hosted by the Protection Engineers Group. I've been a member since 1981. It's a really good group. It deals with, we originally started dealing with electrical protection issues and things of that nature, but we've now expanded the work that we do. And it's really where the ATIS Step Committee writes standards. ATIS PEG's main goal is through education. And we have an annual conference where we bring leading experts in various fields of power, engineering, telcos, suppliers, to discuss the latest issues in the field. So we go over field issues, standards issues, and the way I like to explain it, it's experts teaching experts. For example, I've been doing this for 43 years. There's probably not many courses where I can learn as much as I learned from the experts at the PEG conference. Again, you can learn more about PEG at the ATIS website. If you need any questions, you can reach out to me or others. We have a good website that not only lists the upcoming conference, but also lists all the previous presentations. So we have a wonderful library of technical information at the ATIS PEG website that you can look at throughout the years and all the different issues we've addressed. Next slide, please. So at this point, I'm going to turn over the presentation to Curtis Ashton, and he'll go through his slides, and then Richard will join as well. Again, thank you for attending.
All right, so I'm not going to spend a whole lot of time going over my quote unquote credentials. Just suffice it to say that I've been doing this for 39 years since I got out of high school. Been dealing with batteries and stuff. And the one thing I want to stress here is NFPA 855 is a big document relatively, and there's no way we have time today to cover all of it. So we're going to cover, because ATIS is the Alliance for Telecom Industry Solutions, we're going to cover specifically how 855 applies to telecom. With that, I'm going to turn it over to Rich to introduce himself. Next slide.
Okay. Thank you, Curtis. Thank you, Ernie. Yeah, and thank you, ATIS and ATIS PEG for having us here. I'm Richard Kluge. I'm a NEBS and fire code expert with NEBS Corps. I started my career about a little over 30 years ago with Belcor, then Telcordia, then Ericsson, and now NEBS Corps, working with Ernie and Curtis. We've all worked together for a few decades now. I'm a mechanical engineer. Been basically working in the NEBS area my entire time. If you're not familiar with NEBS, that's basically the environmental compatibility requirements for telecom equipment, making sure they're working at the right temperatures and fit within the doorways and space planning within buildings. Where I work mostly inside buildings. Ernie, I always think, works mostly outside on the outside plant, and Curtis is working, both inside and outside on everything that's batteries, is the way I look at it. I do represent ATIS on about maybe 9 or 10 NFPA committees, 75, which is IT, 76, which is telecom facilities, as well as 855 and others. I'm also the sort of the primary author or manager of several of the old Telcordia standards that were developed over the years, like GR63, GR1089, which are the NEBS ones, also ones for data center, installation quality, and several other battery-specific performance and reliability GRs as well. And I'm a principal member on 855 and represent ATIS, and I've made lots of friends on 855, and I won't say enemies, but there's a couple people that I rubbed the wrong way, because I think when 855 first rolled out, they really had no idea that telecom was a big battery user, and this was going to impact and clash with some of the telecom usages. And that's what I've tried to educate them with over the years. And I think with Curtis's help and Ernie's help, we've done a pretty good job of that. So that's it. Nick, go to the next slide.
So basically, in the United States, I was doing a webinar earlier this morning where someone asked a question about, it was to a former fire chief who provides training on solar panels and battery systems. And someone asked a question, well, how do you know where the batteries can go? Well, that depends on what city you're in. And this was for residential, that was the question was asked. And so the point is that in the United States, we believe in home rule. The 10th Amendment to the US Constitution says if it's not dictated to the federal government, it's left to the states and the municipalities and counties and so on and so forth. So that means that there are model fire codes and there's a model electrical code, the National Electrical Code, which Ernie talked about. But unlike the National Electrical Code, which gets pretty much universally adopted, the fire codes are not, people get a little more picky as to what they want to adopt and change. And they're not as, the jurisdictions are not as up to date sometimes at adopting the latest code. Even with the electrical code, there's some lag, but there's even more lag with the fire codes. I've seen jurisdictions that are still on 2005 code cycle. And you have the two model codes, IFC, the International Fire Code, and NFPA 1. And so even 855 is now driving those two, the battery sections of those two, but many jurisdictions haven't even adopted the latest editions of the model codes, which refer to 855. So it takes a while for each jurisdiction to get there. And even when they get there, the fire marshals, who are essentially the authorities having jurisdiction, and the architectural engineering firms who are the ones designing the systems, they're learning the code changes as they go, and they often misinterpret them. And so I spend a significant amount of my time explaining to architecture and engineering firms and fire marshals, here's where the codes are going, here's where they've been, and then we're going to try to give you guys a little bit of education on that today. With that, next slide, and Rich is going to give us a little bit of history of where it started, the fire code started regulating the batteries.
Yep. So next slide. Okay. Yeah. So this is a map I put together for some the carriers back in the fall, and it shows the statewide adoption of the different fire codes, both the International Fire Code and the NFPA 1 Fire Code. And you can see how it really is all over the map, like Curtis said. There's still some states using the 2012 version of the International Fire Code, so something going on 13 years old. If you look at the evolution of 855, as we're going to talk about, it started to appear in the NFPA 1 Fire Code in 2021. It was first referenced in the IFC in 2024, but no one's adopted the 2024 code yet. There's still some discussions of that, that's being considered, and it'll happen soon, but there's definitely a lag between what's developed as a standard by the NFPA and what the industry is moving along with and what is adopted as an enforceable code. If you look at most content in the fire code, it probably hasn't changed much from 2012. So if you're in Tennessee, for the most part, you're probably fine. But with respect to energy storage systems and batteries, there's been dramatic changes in the codes, and that's where you really need to be aware of the latest changes and start to incorporate them in designs and in in your planning. In fact, the battery area is changing so much, or the energy storage area is changing so much. The advice from some of the code people is don't wait till the state adopts it. Basically start building and designing towards the most current standard now, even if it's not adopted by as a code yet, because otherwise you'll be left behind. And that's really good advice for telecom applications, because one of the annoying things I hear in some of these code discussions or code developments is, oh, you can make this implementation, you can have this feature, but it has to be dependent on the approval of the local AHJ on a case-by-case basis. So they'll try to put that into the code as kind of a mealy-mouthed way to soften the code, or they're not too sure if something's really advisable. They'll leave it up to the local AHJ. And that might work well if you're building one power plant or two power plants in the country. But when you're operating a telecom network that touches on every AHJ, every state in the nation, you can't go case by case and argue for individual unique technical features and changes. So it really does a disservice when code people start putting that sort of language into the code to make it that specific. But sometimes they're coming from a perspective of one or two installations as opposed to a large telecom footprint that goes across the whole country. So let's go on to the next slide. And I'll touch on here. This is just some of the history points of the fire code and its development. If back in the 90s, there was, basically 3 different code making organizations that were somewhat regional, a sort of a western states, a southern states, and the northern states. Those put together a set of fire codes. Each had their own fire code, and one of the early recognition was that lead acid batteries, as used by the telecom industry, clashed with the codes. They wanted to, the code people wanted to treat the lead acid and the large amounts of lead acid in batteries as a hazardous occupancy. If you strictly applied the code, that would have been how it was treated. But the argument was, well, these aren't really that hazardous. They're in a special use. They're important to the telecom network. So they reached a compromise. They said, hey, look, if you include, certain features and put some restrictions in Article 64 of this Uniform Fire Code, we will not treat them as a hazardous occupancy. But here's the rules you have to follow. You needed to have, smoke or fire detection. You needed to have separation from other occupancies. You needed to have seismic protection. So they listed about 6 different features of safety caps and so forth, that and ventilation that would make them safe. And said, if you follow these rules, we won't treat them as a hazardous occupancy, and that worked very well. There were some events that influenced the rules at that point. In 1994, there was a fire at a Pacific Bell central office in Los Angeles. They call it the LA Grand battery fire, and it happened around 1 o'clock in the morning. There were workers who were making reconfiguration changes to the battery plant. They had installed temporary wires to the battery plant, to one of the battery strings. A rectifier turned off, caused the battery to discharge unexpectedly, as it's supposed to do. But the wires that connected the battery to the plant were undersized and began to overheat and smoke and eventually caught fire. So basically they had a small fire, but it was somewhat disruptive, and it caused a 12-hour loss of 911 service to Los Angeles and some wider outages and so forth. The fire response was a little bit complicated by the fact that it's a large building. It has 3 towers of, one tower was 17 floors. The adjoining tower was 12 floors. There's one tower that's 9 floors. Some of the floors interconnect, some don't. The battery installation that caught fire was on the 13th floor. So it's kind of a well-documented event that was studied. The fire response was very good. They were fortunate that the responding crew chief had been to the building before. He was familiar with it. They were able to quickly gain access to it. They put the fire out. The fire was reported very early because there were people in the building working at the time doing that observed it. And the fire was pretty rapidly extinguished. It only took between the estimated 50 to 100 gallons of water to put the fire out. But there was quite a bit of smoke. They had to operate a smoke removal system, which worked well. So they had quite a few lessons learned with regard to battery fires from that event. The actual fire damage was very small. About 50 square feet of equipment was sort of burned and damaged. There was 10 battery cells or cases that were involved, and some cabling. And they lost about, I think, about 30 or 40 gallons of electrolyte were spilled, but kind of washed, diluted by the water. So after that, there was a bigger push for recognition that spill containment or control systems were more, revisited, make sure they were enforced and so forth. Kind of tightened up the inspection and use of those. So that was one, probably the largest telecom battery fire that we've had with regard to batteries. Another incident that happened later was a ventilation concern and explosion at a Sacramento, called, I think it's Rancho Cordova is the town, data center. It was a data center that was essentially abandoned, but they left a UPS system with flooded batteries in position. They left them on charge. Some of the batteries were over 4 years older than their recommended age. So some of the batteries had internal shorts. So essentially they overcharged the batteries for a long time, several weeks. Meanwhile, the air conditioning was turned off, the ventilation was turned off. So they basically hydrolyzed, these batteries, created a lot of hydrogen and left the building all sealed up. And supposedly, I think there were reports that for several days before the explosion, people could hear hydrogen sensors and alarm from outside the building, neighbors, but no one said anything. And eventually the top of the building blew off. So no one was hurt, but there was an explosion caused by basically battery abuse, where they really just tortured these batteries and caused an explosion. No one injured, but that drove some other concerns that ventilation systems should be monitored by fire alarm type systems and reported to central stations and so forth. So, all these events do play into the code. Whenever there's a fire, an event, an accident, it does ripple through the code and get implemented. But in terms of the evolution, the IFC was sort of the main fire code. If you look at from the previous chart, we see that's the most widely used one. There's also NFPA 1. Each of those addresses energy storage systems or batteries in respective chapters. In 2018 was the first edition of the IFC to really get a wholesale upgrade. They took sort of the original UFC 1997 section, really went through it from the get-go with a fresh pen and rewrote it to address lithium-ion and not just batteries now, but what they called energy storage systems. And that was published in the 2018 edition. Similarly, there was work started around the same time on NFPA 855. That first edition came out in 2020, and NFPA 1 adopted 855 in the NFPA 1 2021 edition, and IFC adopted the 2023 edition of NFPA 855 as a reference in 2024. And that's kind of where we are right now. Okay, now back to you, Curtis. We can go to the next slide, Joe.
Next slide, yep. All right, so here's some of the things that were key telecom traditional battery technology exemptions in NFPA 855, realizing that traditional battery technologies really are not that big of a fire risk compared to lithium ion. So lead acid under 70 kilowatt hours was exempt. And then 1458 amp hours in a nominal 48 volt DC telecom plant, that's where you're completely exempt. Once you get above that, you still have a lot of exemptions, but you're completely exempt if you're below that. If you have a UPS and you're a telecom company, because telecom companies have UPSs too, if they used lead acid or NiCad and a UL 1778 listed cabinet, those are exempt from the explosion control and other listings as well. In very small buildings, the lead acid and NiCad were exempt from fire and smoke detection. And as long as the lead acid facilities complied with NFPA 76 detection requirements, which are fairly stringent, then lead acid was exempt from most of the fire and smoke detection. NEBS compliant equipment buildings, in other words, if all the equipment's NEBS compliant, it's flame retardant. And so they don't need a fire suppression system. They have to have fire and smoke detection, but they don't need a fire suppression system. And you don't have to have a fire water supply for really, really tiny telecom buildings. VRLA was not required to have spill containment, which makes sense since it's a mobilized electrolyte and can only spill a few drops. And negative 48 volt DC systems can use industry install and removal practices. Next slide. In other words, rather than having to use the install and removal practices in NFPA 855 and come up with brand new stuff, they could use existing. Lithium ion and sodium nickel chloride, less than 20 kilowatt hours were exempt. So smaller, it was considered these newer technologies were not, how should I put it, were not as safe yet or proven to be safe. So yet they've started being regulated at a smaller value, 20 kilowatt hours, much smaller than 70 kilowatt hours. And they were exempt from spill control because neither of those battery technologies can spill. And normal ventilation, although they do have some significant, especially the lithium ion, some significant requirements for emergency ventilation. But normal ventilation, they don't release gases. And then they're exempt from flame arresters too, because they don't release gases. They're a sealed battery under normal conditions. Next slide. Key telecom regulations in NFPA 855, the 2020 edition, that apply to all battery types. You got to have signage. You have to have maintenance documentation on site. You have to have your SDSs, what we used to call MSDSs in the old days, and you have to train your maintenance personnel. Next slide. Here's some traditional battery telecom regulations in the 2020 edition. If you're more than 1,000 gallons of electrolyte total, you require spill control. That's actually a lot of batteries. 8,770 amp hours at 48 volts. You have to do calculations and you can get them from the manufacturer, do them per IEEE 1635/ASHRAE 21, and that includes VRLA. VRLAs are not sealed batteries. I don't care if the manufacturer, even my own company, writes sealed on there, has a one-way pressure valve, and they will gas a small amount. You have to do the calculations to show the AHJ that you're not going to exceed 1% hydrogen, or you've got to overventilate the living crap out of the space, and that's not a good thing from an energy perspective. You have to have on-site neutralizer spill kits for flooded lead acid and NiCad. And VRLA needs a method to detect and control thermal runaway. Back in the old days, we called it thermal runaway, and then we learned what thermal runaway really was when lithium-ion came along. And so we've been renaming thermal runaway in lithium or in lead acid batteries, mostly VRLA. We've been renaming it thermal walkaway because it's very, very slow. And the way that's typically done is typically with temperature compensated charging. And then all lead acid and NiCad have to have flame arresters. Next slide. Lithium ion and sodium nickel chloride over 20 kilowatt hours have to comply with the following. You have to have site-specific emergency operations plan. These don't apply to lead acid. But if you mix batteries in the same room, then you have to have a hazard mitigation analysis done by a fire protection engineer. You have to have UL 9548 test results for these modern batteries. That's a large-scale fire test. If you're indoors as opposed to outdoors, you have to put 3-foot minimum spacing between these battery types, or ask for the AHJ of 50 kilowatt hour maximum cabinets, stands, whatever. And that's what that little picture over there to the right shows. The AHJ can waive that based on the 9548 testing that's been done and a report written by a fire protection engineer that convinces them that these are not likely to spread. However, many lithium-ion batteries are likely to spread. So that's why they often go in outdoor containers when they get into larger sizes. Telecom 48-volt lead acid and NiCad are exempted from that spacing. Modules listed to UL 1973, and systems have to be listed to UL 9540 for your NiCad, not your NiCad, sorry, your lithium-ion. They have to have that listing, whereas lead acid doesn't. You can't put them in a basement electrical room like traditionally was done with lead acid batteries. So you could do it with lead acid, but you can't do it with the lithium ion. And the idea is that the firefighters need to have easy access to fight the fire. You also couldn't put them on roofs over 75 feet for the same reason. You had to have commissioning and decommissioning plans and results. And they have to have a battery management system. That is not a battery monitoring system. That's a battery management system. There's a BMS built into these batteries to prevent them from being overcharged, undercharged, over-discharged, charging outside their temperature range, etc. And you have to have deflagration, ventilation, and explosion control per NFPA 68 and 69. So that's the lithium-ion specific stuff. Next slide. There's a few more in 2020. Lithium ion and sodium nickel chloride were limited to a max of 600 kilowatt hours. And the AHJ can approve larger installations, which obviously there's much, much larger installations in the energy storage world, but they have to have a hazard mitigation analysis plan, which usually means they put them outdoors in steel containers that are separated by anywhere from 10 to 13 feet typically, and that way they're not worried about the spread so much. Lithium ion and sodium nickel chloride over 50 kilowatt hours have to have high flow sprinklers installed. It's about 3 times the typical NFPA 13 rate. And I showed this picture of this grandpa here. I happen to be a grandpa, but that's not me. And I put an X through him because grandfathering is what most codes do. So, for example, with the National Electrical Code, the National Electrical Code now requires for a lot of outlets in the house, they require that the breaker box have what's called arc fault circuit interrupter protection, which is different than GFCI. It's an AFCI breaker. It's got a long coil of wire, pigtail on it. That's required. But if your house was built before that started being required, back in, mine was built in 1991, my house is grandfathered. Now, if I go do a wholesale panel retrofit, then yeah, I've got to follow the new code. Well, with 855, unlike other codes, the AHJ can decide that an existing installation that was installed before 2018 or 2020 or whatever, he can make the decision that it's too dangerous and needs to be fixed before he'll let it operate. Or he may give them some leeway with time to get it fixed and say, hey, no, I'm going to red tag it if you do not fix these things. So we all know that the older systems are much more, of lithium-ion batteries are much more liable to go into thermal runaway. And so they may require some design changes. Next slide. Okay, it's Rich's turn.
Yeah, back to me. Thank you, Curtis. Now that was good. Yeah, and speaking to the changes that Curtis mentioned in the grandfathering, we're definitely finding out more and more as 855 evolves, improvements that we didn't see that the first time. So the code's definitely changed as it's gone along. So we've seen events that we now have to prevent that we didn't realize were issues at the beginning. And that's why the reason for the lack of grandfathering, because there's definitely failure modes that weren't anticipated that now we're trying to catch going forward, and permitting AHJs to go back and say, hey, this system, even though it was installed to the code at the time was not perfect, and there's things that were that should be brought up to the newer code, and that plays to the issue of how quickly these things are changing and evolving and how we need to respond. One change that was made for the 2023 code is sodium nickel chloride batteries. They were made by FZ Sonic and now Horine. They had an exemption increase from 20 to 70 kilowatt hours. So the code, the standard, I should say, 855, has a threshold of limits of when it applies, how large of a battery or an ESS system can be before the standard applies to it. So for lead acid and NiCad, it's 70 kilowatt hours. For lithium-ion, it's 20 kilowatt hours. Sodium nickel chloride was able to increase their threshold quantity from 20 kilowatt hours to 70 kilowatt hours by bringing test data to the committee and showing them that it's safe and relatively safe, and what its failure modes are and how it performed in various tests like UL 9540 and 9548 and so forth. So based on that data brought to the committee said, yes, this sodium nickel chloride is a safer technology than originally thought. So they increased the threshold quantity of when the standard applies from 20 to 70 kilowatt hours for that chemistry. Similarly, there's I mentioned 70 kilowatt hours for lead acid batteries. That's the threshold. That's really based on long-term discharges as we use for telecom, maybe some other utility applications for peak shaving and so forth. For UPS applications, cells are typically rated in watts per cell, and there's a conversion from watts per cell to kilowatt hours that was made, and it actually is beneficial to lead acid. Lead acid, it turns out the faster you discharge it, the less real power you get. So by discharging the UPS cells faster, as they typically do, or sizing them based on that, you can actually have a slightly larger UPS plant than would be permitted if it was a long discharge type plant. So it's a little bit of a relaxation, but still, still applies. Even UPSs and traditional telecom 48 volt plants have to comply with the code when they're over 70 kilowatt hours for a telecom 48 volt plant, traditional plant, or 1166 watts per cell for a UPS type plant. And if it was a zinc 5 brand nickel zinc plant, that would be a one string plant would fit and underneath, and maybe the code would not apply to it. Another point that's unique to lead acid is that you don't have to have listed lead acid system level listing. If you have a listed UL 1973 lead acid battery and the other components that you're using with it, the charger, the inverter, are listed. Most of the ESS systems, this standard is going to say have to be listed specifically to 9540, which is the UL listing standard for energy storage systems. But there's a sort of a tradition or practice for years, for decades, that people have kind of built their own battery plants by purchasing listed chargers, listed rectifiers, and so forth, and inverters, and just regular batteries. So if you can use a listed battery and all the other components are listed, you can put together your own system. You don't have to go through the system level 9540 process that looks at integrated type systems. So that's a unique twist to the standard that's specifically addressing the way lead acid batteries have been used. In addition, there's concern with fire spread between energy storage systems, and for that reason, they're trying to limit the size of an individual rack of batteries and how close they're spaced together. So they don't want very large fires, and they don't want fires to spread from one rack or stack of batteries to an adjacent stack. So they limit, in general, the size of the battery stack or module, they don't call it, we call it strings, they call it a module, to 50 kilowatt hours. And between every 50 kilowatt hour stack of batteries, you need to have a 3-foot spacing. It's really just a lithium concern. I mean, lead acid batteries don't tend to burn in that fashion as we typically use them, or NiCad, or lots of other technologies. So they've included an exemption for lead acid, that if the lead acid battery is listed to 1973, you can have a stack or a string up to 250 kilowatt hours before you have to separate them by 3 feet. For telecom specific applications, for 48 volt and for everything that's good about telecom, they've actually gone even broader. There's really no limitation, but there is wording. You could misread the code and say you can't have 2 large tanks of telecom batteries next to each other. 48 4,000 amp hour batteries would be over the 250 kilowatt hours, but telecom has an even broader exemption, so you have to make sure that's being employed and that the AHJ understands that. There's no limit in the size for telecom. In addition, you can have that's 4,166 watts per cell for a nominal 48 volt DC string with all the strings parallel. So there are limitations on how large the systems can be and how closely they can be spaced together. In addition, one of the concerns is rooftop installations. Firefighters and responders have a big concern with rooftop access for both battery systems and also solar systems. As Curtis mentioned before, there's a lot of interest in these solar applications tied with the batteries. Solar systems are often on the roofs, and there's often batteries with them, and there's often telecom applications of cellular equipment on roofs with batteries. So that's a concern for the firefighters. They don't want to be too close to the roof. They don't want to be falling off a slippery roof. Most of the telecom sites are on a flat roof, as opposed to maybe the solar sites. But rooftop access is something that they're concerned about. They want to have that, make sure that's managed and safe. Anything above 75 feet requires AHJ permission. That's about the highest they can go up, on a cherry picker or a ladder access. So if it's a rooftop installation above that height, you need to have AHJ permission, but it is more likely to be granted for lead acid and NiCad than some of the other chemistries, because they're basically less combustible. If you have a lead acid battery in a UPS that's not required to have a fire suppression system, typically telecom applications in general don't require fire suppression systems either. And for regarding NFPA 68 and 69, those are NFPA standards to address explosion control. That's NFPA 68, like relief panels, sort of controlling the explosion and how much damage it does. NFPA 69 is explosion prevention, venting gases or taking other means to prevent an explosion. The current 2023 edition of 855 allows you to do either explosion control or explosion prevention for lithium-ion or sodium nickel chloride, but you don't have to do both. You got to pick one or the other. That actually changes in the next edition, where we start to get more into. There's more of a push towards 69 explosion control as opposed to explosion or prevention as opposed to control. So the current trend is to get away from control to prevention and insist upon NFPA 69, but that's being challenged somewhat. In addition, there's lithium-ion storage rules in Chapter 14. They were put in basically to address things like recycling centers, places that collect lithium-ion storage. You put a lot of lithium-ion storage batteries in a bin. They could be a fire hazard. So there's rules that apply to the types of protection needed at those facilities. And it now applies to not just old recycled batteries or damaged batteries, but also to new batteries. Okay, so go to the next slide.
Hey, Rich, if I could just pop in on that storage rule. So basically, unless you have high volume sprinklers and thermal detectors in a warehouse, if you store lithium-ion batteries in a warehouse, that Chapter 14 requires you to store them at less than 30% state of charge. The UL testing has shown that they will not propagate between cells if they're stored that way, even if they do catch on fire. And unlike a lead acid battery that's required to be on charge to go in thermal walkaway, a lithium-ion battery can catch on fire anytime. It doesn't care if it's on charge or not.
Yep, no, very good. Thanks, Chris. Yes, thank you. This is there's a new draft for the 2026 edition of 855. If you go back to the development process, standards start with sort of a first, public inputs. They make a first draft. They take additional comments. They make a second draft. They publish the second draft, and people can make sort of one more attempt to get a change in. Typically, it's to take something out that's been added, or to insert something that was previously requested and not inserted. Those are called NITMAMs. It's a notice of intent to make a motion, and they take that to they submit that to NFPA leadership. NFPA leadership says, yes, this is valid. This addresses a point that was raised previously. It's not a brand new request. And if so, they'll call it a CAM, a certified amending motion. And those are presented sort of live in person at the NFPA June meeting in 2 weeks. And the proponent has to get up there and argue for the change and try to convince the whole NFPA membership that's present voting that this basically to override the position of the technical committee, or the technical committee made a mistake. And there could be times where the technical committee does make a mistake. They realize it, they support it. But generally, it's a request for changes, often from segments of the industry that were affected by a change that want to speak against it, or try to have something reversed. There's been, I think there's like about 8 or 10 changes submitted as NITMAMs or CAMs to NFPA 855. Several of those address a new requirement for large-scale fire testing. We mentioned there's a 9540 listing requirement for the system for energy storage. There's a 9540A assessment of fire spread or spread between cells, like thermal runaway propagation. And there's also now a requirement for explosion testing. Okay, that could be separate from 9540A. And now they're saying, hey, even with those that we've used in the past, they're still seeing fires that were not predicted. They want to have another large-scale fire test to say, if some other mechanism came along that we didn't model and caused the system to go on fire, either large water leaks or short circuiting, or exterior fire, how much, if this thing does fully evolve in a fire, what's the damage? How much fire comes out? How big is the fire, and so forth? They quantify it. So there's a new push for large-scale fire testing, they call that. That's some of the AHJs have been asking for outside of the standards development cycle, and now the standards trying to step up and put something in place to deliver that. There's UL is looking at updating 9548 to address that. There's a 9540B, I think, that does that for residential, and CSA that has a standard that's written a process to do it as well. CSA 800, that's an option that could be considered. So there's No, so as people push in for new tests, there's some people say, hey, it's really not well thought out. It's kind of, the tests aren't specific. There's general guidance, but they don't think it's enough. So there's people who are pushing against the test, want to remove the large scale fire testing. There's also a requirement to have electric vehicles that connect to the grid be classified as energy storage systems, and that pulls in some additional listing requirements if they're going to be used like that. And there's people who are, think that's not a good idea and are against additional listing requirements that might apply to vehicles used as energy storage systems. There's in the latest edition, Curtis mentioned the sprinklers. There's also in earlier editions options for other types of suppression systems, but some of those have been struck out. There's generally a feeling that, hey, some of these newer systems or the hybrid systems, maybe clean agents and other ones don't work as effectively on lithium fires, so they were removed as options. But there's folks who, maybe rightly so, say, hey, the standard's not just about lithium. These could have been fine for lead acid or other applications. They should be put back in. So they're going to argue that some of those removed suppression technologies should be put back in. That seems like maybe that's a reasonable request. There's a requirement. There's an amending motion to put back in the need to have both NFPA 68 and 69 as explosion protection measures. There's a request to push. There's a new requirement for emergency power to be put onto monitoring systems. 24 hours of emergency power. That if you had a large ESS, maybe in an outside plant application for a commercial utility, and there was a fire, they want to monitor it for 24 hours and have all the reporting come from the BMS and so forth, and the ventilation systems and the protection systems be powered on, even though the ESS itself might be off. So they're asking for 24 hours of emergency power, and some folks are saying, that should be struck. It's an excessive requirement.
Should we go to the next slide?
Yeah, I think that's it. Yep, next slide. Go next slide. Okay, so this speaks to other beneficial changes, I think, that were for lead acid, I think, that are in the latest edition. There's certainly broader, more beneficial exemptions for lead acid. We've tried to treat all aqueous chemistries the same that are not flammable, and I think we've been highly successful in that. In the old codes, you saw there was definitely a distinction between lithium-ion and aqueous. The tables were different in the old fire code, and I think we're starting to work our way a little bit back to that and treat aqueous chemistries as something less flammable than the other chemistries, which is beneficial. There's a push to get more benefit out of UL listings for batteries. There are VRLA batteries that are UL 1973 listed, and we want to take advantage of that and get some additional exemptions from some of the requirements when those are in place. But however, we realized that NiCad and flooded lead acid batteries aren't yet available UL 1973 listed. They were never required to be listed before, and they're not in the marketplace now. So we've brought in the exemptions to actually allow for either listed UL 1973 regulated lead acid batteries to have exemptions, or flooded cells or NiCad cells. So it's good. So we've actually, as part of broadening those exemptions, we've added, we've addressed the fact that some technologies aren't yet available listed, even though ideally everything would be listed at some time in the future. I mentioned it came up in the NITMAMS about the 9540A testing possibly not being adequate, and that there's a need for large-scale fire testing. That's the guidance that's added in Annex G as an example, and there's definitely progress being made within UL and other testing organizations to develop a more consensus-based large-scale fire test that could be applied and pulled into the standard in the future. And I think there's a maximum energy storage, maximum energy table that would limit what size of an installation could go, particularly in an indoor non-dedicated use building. Lead acid and NiCad did not have a maximum energy limit. what lithium, flow batteries, and other chemistries did. That if you want to exceed the maximum allowable energy, you could do it, but you basically needed to do a large-scale fire test or have 9540A testing that was very positive, acceptable by the AHJ, and have a hazard mitigation analysis showing that it was okay. They've struck the maximum energy storage table. Basically, there is no maximum limit anymore, but the HMA is now mandatory, and for chemistries other than lead acid, NiCad, and the aqueous chemistries, you need to do the fire testing anyway. So the MAQ table, the maximum allowable quantity table, has been removed, but there's other requirements that you have to do, hazard mitigation analysis and so forth, which is a good idea. That was a good change. I think it's important that every chemistry be analyzed and make sure that it's safe using hazard mitigation analysis. Every installation has needed for the last couple editions an emergency action plan. That basically says if I have an energy storage system, a UPS, somewhere at a facility, if there is a fire, people know how to evacuate, get out. That's a general OSHA requirement for a workplace. Now, everyone also needs an emergency response plan. That's basically a document that tells the firefighters how to respond and address to an emergency. Okay, let's go to the next slide. We'll wrap up, I think. Okay, so just in retrospect, I think the initial emphasis was on fire in 855, basically written around lithium-ion, and the need to have it listed in 9540. Early on, stuff wasn't even listed. It was quick recognition, though, that even 9540 listing wasn't sufficient, and they pushed for wider use of 9540A to assess the thermal runaway propagation. That's not, as Curtis mentioned, not VRLA based, but lithium based, cell to cell to cell, fire propagation. Early on, they found after an event in Arizona that a fire is not the only issue. We have to worry about explosion, and that the risk, even when we put the fire out, the gases that are released are explosive. Even they're more explosive when there's no fire. That drove NFPA 68 and NFPA 69, explosion sort of control and explosion prevention, into the testing. And now they're saying, oops, they're still having large fires, fires. Add large-scale fire testing on top of the other tests to say, even if everything really goes wrong, if this thing does catch fire, what happens? They need to know that. 855 is broad with respect to its chemistries and the ESS technologies, but 90% of the focus, I'd have to say, is on lithium-ion batteries because they're the bigger hazard and they're also the newer applications. And comparing evolutions from 2020, 2023, 2026, it's difficult to manage with 855 because in every update, there's, to a large extent, large-scale reorganization and movement of content within the standard. Okay, next slide. And I'll just quickly touch on this. We talked about this whole evolution. Back in the 1997 edition of the UFC, I think there was maybe 6 or 7 topics under batteries. This is the 2015 IFC edition. We're up to 9 topics. The 2018 edition of the IFC, we added an additional 13 topics. So it's getting more complicated. And go to the next slide. Just the list of topics. You can see here it's up to, these are just additional topics added to 855 into a 2023 edition. So we basically went from like a page and a half to a page and 3/4 of requirements up to about 25 pages of requirements, that installations have to meet and so forth with the latest edition, which again, it's the older technologies. The telecom plants are overly affected by that, but we're not. They shouldn't be. Is sort of the driver point. So I think that's maybe
the last slide.
that's it. Well, we're good. Okay. So yeah, any I guess in summary, I think we're getting better. The standard's moving in the right direction. I think every industry is being well served. It's getting better for telecom. It's getting better for the utilities and so forth. It's addressing real uses. But as Curtis mentioned, the codes themselves progress slower than the standard. So don't wait for the codes to catch up. Look at the latest standard and design and build towards it, and get involved if you can. You can always be on a task group, even if you're not a technical committee member of an NFPA standard. That's it. That's all I have.
So on the, leave this slide up here while we answer questions, if that's okay.
Yep.
Because I want people to be able to get a hold of us, because I don't know if we're gonna have time to make it through all the questions. Our ATIS organizers, can you tell us, is it gonna cut us off right at the top of the hour?
Yes, it will, but we can answer any unanswered questions by email after.
All right, so
Okay.
I'll just start with question number one. I'll just go through them as quickly as possible. What's an HMA when you have mixed batteries in a room type? Hazardous mitigation analysis, it's done by a fire protection engineer typically, and they look at all of the different hazards in there and then decide, they give you design advice. And typically your fire marshal is going to make you follow whatever their advice is. And that's what the HMA is. Question number two is, do lead acid and NiCad that are bigger than 48 volts DC and greater than 70 kilowatt hours require the UL 9548 testing or the UL 1973 listing to exempt them from the 3-foot separation requirement? And in the latest editions of NFPA 855, no, but to Rich's point just a minute ago, it depends on what's your fire code that's adopted. If it's not up to date, addressing the latest one, you may have an AHJ that may, how should I put it, may require you to do certain things. I've had success in showing AHJs, fire marshals, and architecture and engineering firms that, hey, here's where the code was, here's where it's going, and here's what, and some of them will back off then and say, okay, we see where the code's going, and that's where we want to do it. So yes, they are exempt in the latest edition of the standard, but not necessarily in the code that's adopted in your jurisdiction. If an issue happens in a grandfathered facility, who takes the blame? I can tell you it'll end up in court every single time.
Mm-hmm.
And whether or not that gets settled out of court, which it usually does, but it's usually a several-year process. I've been involved in many of them already. The battery manufacturer points at the integrator points at the battery manufacturer. It's a mess. So as far as who takes the blame, it's definitely not NFPA, but the battery manufacturers generally, they want to point fingers, and so do the integrators. Nobody wants to pay the bill. Question number 4, can you speak to whether the updated 855 requirements, how they apply once the latest edition of the IFC that references the standard is adopted by the AHJ? They will apply universally. So basically, chapter 1207 or section 1207 of the IFC, for example, will refer directly, in the 2027 edition, will refer directly to NFPA 855. It won't have its own requirements. NFPA 1's the same way in chapter 52. So once they get the latest editions adopted, then 855 becomes the governing part of it. It'll still be in 1207, but it'll say, see NFPA 855 section blah, blah, blah. Next question, is the kilowatt hour limit per battery room or per building in total? It's per fire suppression area. That's what it is. So it's usually walled off fire rooms. So it's per the room usually, but there are exceptions to that.
Yeah, that's a good question. I got yelled at one time for pointing out that in a telecom office, you can have different battery power plants on different floors. Like to the traditional guys that are building commercial, grid systems, that was unheard of. Everything, it's a dedicated building with this. It's all in one spot. They were shocked to hear that you can have a power plant on the basement, and the 3rd floor, and then the 6th floor, and that you had to look at each floor separately and not the building as a whole. So that's a good point. That's another nuance to telecom that's not universal.
There's a question and a follow-up that says, why did lead acid get exempted? And they said, well, I realized that lead acid are not flammable the same way. They have a liquid electrolyte, mostly of water, but the cables that connect to them are somewhat flammable. So obviously the copper itself is not flammable, but the insulations, in telecom, most of the time the cables do have flame retardants added to the insulation.
Sure.
And so, yes, can they smoke? Yeah. Can they burn? That's a different story. They're likely to smoke and not burn. Question 7. Regarding the NIPMAM, when you're referring to lithium ion, what about LFP? So lithium ion is a family of chemistries. Some are more dangerous than others, more likely to go into thermal runaway. And the questioner is correct that LFP is less likely to go into thermal runaway than most of the chemistries. LTO is even less likely than LFP. But basically the way that our money says, in God we trust. I like saying in God we trust, all others must have data. That's the way the NFPA 855 committee looks at it. Bring us the data, and then we will make exemptions for LFP and LTO and things like that if you bring us enough data. So that's really where it's got to get to for different chemistries. And then the last question that I had on here had to do with hybrid supercaps. The hybrid supercaps is another technology. It's a combination of a supercap and a lithium-ion battery in most cases. And once again, show me the data.
Yeah, that's an area where within the technical committee, we need more expertise on hybrid supercaps. It's woefully underrepresented. So if you're interested in hybrid supercaps, definitely get involved, at least get on the mail list, and join a task group and lobby for it, because we definitely need help there. No one's speaking to hybrid supercaps on the committee on a regular basis.
Yeah, what I can say is that in NFPA 70E, which is electrical safety in the workplace, they are looking at requirements for hybrid supercaps, at least from a safety standpoint for workers. Thank you.
Okay.
Yep.
Good.
That does it for the questions that came up on the Q&A. So we're a couple minutes past, and so we didn't get cut off. So I think we're good.
Again, thank you everyone for attending. You have our contact information if additional questions come up. Again, you'll be getting information from ATIS with regard to how to access the presentation and slides. Thank you.
Great. Thank you.
Thanks,
Bye.
everybody.
Thank you, everybody. Bye-bye.
Bye-bye.